and maybe like coulometry or something, but like everywhere else, kinetics, acid base, equilibrium, everything else, concentration, concentration, concentration. It's all concentration. Okay. What was my concentration of H2? I don't remember. H2 is going to be 3 moles in 2 liters. What is that? 1.5. Okay. What is my N2? 2 and 2? Okay. What is NH3? Why is it 0?
Because you don't start with that in the beginning.
I have none of it. I have no moles. Whatever my volume is, 0 or whatever is 0. Okay. So, now the fun part, the change. We don't know how much it changes by. When we don't know how much of something is happening, what variable do we use? X. We make a variable out of it. We just say X. I don't know what X is, but I'm just going to call it X. Okay? This is the point where you start using stoichiometry. And that's why I said this is going to be a kind of difficult problem, higher end problem that you would be expected to do in IB, in Chem Olympiad, AP, whatever it might be. So, if I make 1 and 2, how many of these am I going to make? 3, right? If I make 1 of these, how many of these am I using? If I make 1 of these, how many of these am I going to use? Half, right? Because if I have 2 of these, then I must have 1 of these. If I have 1 of these, I have 1/2 of these. Okay. Which am I going to be making? Am I going to be making NH3 or H2 and N2? Why?
Because it has to go to the right to the actual
I have no NH3, right? I can't make any of this. I have none of it. This reaction can't happen yet. So, I'm going to say that this is going to go down by negative X. Okay? I'm going to say that this is going to go down by negative what?
3x.
Negative 3x. And this is going to be
Increasing by negative 2x. I mean positive 2x.
increasing by 2x, right? So what is my equilibrium? What is my final value? 2x. Why is it 2x? What I started with plus my change is my final. What about right here?
2.5 minus 4x. 1 minus x.
You look at each one individually, in each column. There would normally be like lines if you were given an equalized chart. Yeah, I just didn't draw them. Okay, so this is 1 minus x. This is 1.5 minus 3x. Okay, we now know our equilibrium values. Can we now solve for the equilibrium constant?
Yes.
We were told that it's 1.2 times 10 squared, right? What is my equilibrium constant going to be? No, you quiet. I know you know this. The rest of you.
2x squared.
2x squared. Why is it 2x squared? Where are you getting that from?
NH3 value squared.
And then
NH3 equilibrium value squared. Yep. We need that 2x equilibrium value squared because that's 2. Okay? Divided by what?
1
minus
5
minus-
minus 3x cubed, right?
and then 1 minus x. Sorry, I said and then.
Wow, that's a really gross equation to solve.
Oh, we have to solve that now. Okay, so that's wow.
Okay, so we're going to cut it off here and go home. But so the way you'd finish this problem would be you would solve for x, right? You would solve for x and then you'd plug it into all of these and calculate your equilibrium concentration. Make sense? So let's just say that x ended up being 0.2. What would this be? If we just let that x is 0.2, this would be
0.4.
0.4.
Yeah.
This would be
0.8.
0.8. This would be 0.9. Okay? Does that make sense? Unless, yeah, the probably isn't actually going to work with the value because this is totally wrong. But, ta-da! That would be a high-level equilibrium problem. Do you see why it's complicated? You're expected to bring in a whole lot of things. You need to know how to do an ice chart. You need to bring in the stoichiometry. you need to do really complex high-level math, like multiplying and dividing. And then finally, you need to plug stuff back in. On top of the whole, like, knowing how equilibrium works. Okay? So, next week. Oh, hey, guys, listen up. Important information here. Have all of you signed up for Chem Olympiad?
Yes.
Raise your hand if you haven't. Okay, just you. Talk to Milam, like tomorrow or soon. I don't know when the deadline is. I think it's early March, but the sooner the better. Okay? Alright, one more last thing. Chem Olympiad competition is March 17th. That's a Thursday. It's 3 weeks from yesterday.
It's a half day.
It is a half day. So you can like go home and relax and do chemistry thingies until like 4:30. So March 17th. It's at 4:30. I think it starts at 4:30. Like the exam will actually start at 4:30, but I'll confirm and get back to you guys. It's at U of M Dearborn. We'll give you like address and building and where to go and all that stuff when we come closer to the time. But this means that after today we'll be meeting 2 more times and then we have Chem Olympiad. So next week what we're going to try to do is just finish up the rest of basic equilibrium. Oh, wait, can you guys like answer this quickly, please?
Just one.
Okay. 1 only. Well, yeah, we know this is true, right? If I didn't stress it enough. Forward, reverse, right, equilibrium. Woo. Why is this not true?
It says concentration.
Concentration. The concentrations don't have to be equal, right? We just saw that in our last problem. The concentrations are totally different. But it's still at equilibrium, because the rates are equal. So A, 1 only. So yeah, next week we'll do more of that ice chart thing, and then we'll cover Le Chatelier's principle, who has like the coolest name ever, and then that is it. And then hopefully, like that final week, we can, I don't know, do
We're all gonna ace this.
methane bubbles, it'll be fun. And were you recording me?